What exactly is a tangent? The term tangent can actually mean a couple of different things. A tangent line is one that touches a curve in exactly one spot. For instance, a circular wheel touches one point on the ground, which is tangent to it. We can play with this tangent line and find an interesting pattern in how it works. We'll connect a tangent line to a point on the circle and spin the point around. Instead of extending our tangent line on indefinitely, we can limit its length to be between the tangent point and where it intersects a horizontal line that runs through the center of the circle. As we rotate the circle, the length of this section of tangent line will grow and shrink. At 0 degrees rotation, the tangent line has no length, since it's smashed directly against the horizontal center line. As the point rotates upwards, the tangent line grows. Bringing the point up higher and higher, the tangent extends out further as it grows more parallel with the horizontal center line, until at 90 degrees, the tangent is perfectly parallel and extends on infinitely. Going past 90 degrees, the tangent line flips as it reaches down to the left for the horizontal center line. The line shrinks back down, returning to a length of 0 at 180 degrees rotation. The tangent line then flips again as it reaches upwards for the center line. It grows once more to be infinitely long as it becomes parallel to the center line, then flips again. The growing and shrinking of the tangent line follows a set pattern. We can consider that every time the line flips, the length switches between being positive to negative, positive to negative. We can keep a trail of this tangent line as it rotates all the way around the circle. Then we can take this trail and line the segments up to be parallel. This sweeping curve that's formed is called a tangent function. At 0 degrees, the tangent value is 0. At 45 degrees, the tangent is the same length as the circle's radius. And then the value quickly sweeps upwards to be infinity at 90 degrees. It then flips to negative infinity just past 90 degrees and shrinks back to 0 at 180. We can find the same relationship from a different perspective in this diagram. We'll take the location of the tangent point and consider its offset from the center horizontally and vertically. As the circle rotates, that location will rise and fall and move back and forth. The horizontal and vertical offsets form a right triangle. Additionally, the tangent line and the circle's radius also form a right triangle. And these two right triangles are similar. This means that how the length of the vertical offset compares to the horizontal offset is the exact same as how the tangent line compares to the circle radius. The ratios are the same as the point rotates around. They both relate with a tangent function. So what can we do with this tangent ratio? If we can find a right triangle and how something is configured, we can use the tangent ratio to figure out unknown values. For instance, if we know the length of a shadow and the angle of the sun, a tangent ratio can help us calculate the height of an object. But beyond that, knowing that patterns such as this exist and seeing how they work helps us to problem solve and to better see and understand the world around us.